machine shop. In reviewing the shop's utility bill for the past 12 months, he found that the highest bill of $2,600 occurred in August when the machines worked 1,200 machine hours. The lowest utility bill of $2,300 occurred in December when the machines worked 600 hours. Use the high-low method to calculate the variable cost per machine hour and the total fixed utility cost. Then show the equation for determining the total utility cost for the machine shop. And finally, if Mark anticipates using 800 machine hours in January, predict the shop's total utility bill using the equation from requirement 2. So we'll start with obviously requirement 1, using the high-low method to calculate the variable cost per machine hour and the total fixed utility cost. So down here, we'll say the variable, we're just going to abbreviate that as V, cost per unit is equal to the change, I forgot the shortcut for delta, so I'm just going to type it out this time. Change in total cost divided by change in volume of activity. And so that means we're going to say the highest cost of 2,600, let's put this in parentheses, minus the lowest cost of 2,300 divided by the highest machine hours, so 1,200, minus the lowest machine hours, which is 600. And so 2,600 minus 2,300 divided by 1,200 minus 600 gives us 0.5 per machine hour. And so then for our total fixed costs, we will say the total mixed cost minus the total variable cost. And we could break that down even further to say the total mixed costs minus the variable cost per unit times the number of units. So now we're going to just pick one, either the high or the low to fill this in. So let's go ahead and use the high. So we have total mixed costs of 2,600 minus total variable cost per unit of 0.5 times the number of units for the high was 1,200 I don't know what's going on here where we can't see. Okay, just have to move that over, I'm not sure. And so then that gives us 2,600 minus 600, because 0.5 times 1,200 is 600, which gives us 2,000 for the total fixed costs. And now that we have this information, we can use that to create the equation for determining the total utility cost for the machine shop. And so that would be total utility cost is equal to the variable cost per unit times the number of units plus our total fixed cost. And that gives us parentheses 0.5 times number of units plus 2,000 as our equation that we will use for total utility costs. And then part 3 said if Mark anticipates using 800 machine hours in January, predict the shop's total utility bill for the equation from requirement 2. And so we can plug 800 into number of units, or maybe we wanted to even call, instead of number of units, maybe we want to say number of machine hours. And so to plug in 800, we would have 0.5 times 800 plus 2,000, which will give us 2,400, but we'll go ahead and just keep doing the math down here. So we have a total, we can predict the total bill to be 2,400 if we anticipate using 800 machine hours in the month of January.